Good morning, everyone, and welcome to chapter 26. So in this chapter, we're going to be talking about biotechnology. If I can get my thing to turn. There we go. So the first thing we're going to focus on is a few definitions. So what is cloning? This is the production, and let me change the color. I just realized I'm still on red. So we're going to go blue. So this is the production of identical copies of an organism. That is an A, I know. I write very sloppy. Sorry about that. Whereas gene cloning is the production of identical copies of a gene. That again is an A. So when you clone something, you're making a copy of the original the original item, and you're making it identical so that you can use it again and again. So we use things like gene cloning in biotech all the time so that we can produce things like transgenic organisms. So what is a transgenic organism? Oh, hello, that's not what I wanted to do. All right. Transgenic organism is an organism that has DNA from another source. So you have taken DNA from another source and added it to their genome, so that now they can maybe grow better, or they can produce certain proteins that they couldn't produce before. And so this is also used in gene therapy, where we take cloned genes and then we are able to use them to modify humans. So if we're going to do this, we have to be able to get that DNA into another organism. And so we do this through a process called recombinant DNA technology. So recombinant DNA is DNA that contains, or a DNA source that contains DNA from two or more sources. So you might have DNA from human and bacteria. That would be an example. So to do this, we have to have some type of a vector that can take the DNA and put it into another organism. So a vector is just a piece of DNA that foreign DNA can be added onto. And so oftentimes we use plasmids as vectors. Plasmids are accessory rings of DNA. So this is not part of the bacterial DNA. So like here you have it's not their chromosome. So here's the bacterial cell, and we have this region in the bacterial cell where their chromosome is located, and that's called the nucleoid region. So this area here would be nucleoid. But bacteria also can have accessory DNA rings, and so those are plasmids. And if you look at it, it also looks like a creepy mouth with two eyes that have no pupils. But anyways, that's another story. So plasmids are accessory rings of DNA that aren't needed for bacterial growth, but can give special characteristics to bacteria. And sometimes we use viruses. So viruses can contain either DNA or RNA, and in this case, they would contain DNA. And then we can input more DNA into the virus. And so when we do this through a process known as specialized transduction, we then are able to take in information into that virus that we want the virus to produce. And so instead of the virus producing viral DNA and viral proteins, they now have this special DNA that's in there from some source. And then they can use that virus to infect another cell to give that cell that specific DNA. Nope, there we go. So there are two basic enzymes used in recombinant DNA technology. So we have those DNA structures, either the vector is what I want to say. And the vector is going to take in information from some other DNA source. But to be able to do that, you have to use restriction enzymes. Restriction enzymes are also known as molecular scissors. What these are enzymes, so proteins, that are produced by bacteria and their function is to protect them from viral attack. So it's kind of, restriction enzymes are bacteria's pretty much their immune system. It's part of their immunological protection. I'm just going to write immune system. Okay. That's a really weird spelling. Look, that's an N, just FYI. IMMUNE, just okay. Restriction enzymes cut DNA at specific regions, and they don't have to, but the ones we care about produce these things called sticky ends. And so a sticky end allows you to attach another section of DNA. It just has to have that exact same sticky end. And then we use DNA ligase, which is a glue, basically like a glue, that seals everything up. So seals the backbone of the DNA once you have attached the new DNA that you care about. So let's just look at this. Here we have DNA from a human. And here we have bacterial plasmid, okay? So again, this is a plasmid. This is their chromosome. And so we take the DNA from the human and we take that plasmid and we're going to cut them both with the same restriction enzyme. What that does is it's going to take and produce the same sticky ends on both the human and the bacteria. We then can put the plasmid and that gene from the DNA together and wait for them to anneal or stick together. So once they get together and they stick together, DNA ligase seals everything in. So the backbone is going to be sealed completely. We can then insert that new plasmid back into the bacterial cell, and then we can grow that gene. And so this is a way to clone a specific gene. And so now we have bacteria that can produce human insulin for gene therapy. I'm going to stop here and we'll get into PCR in our next video. Bye.